Hello my dear students, once again welcome back for the continuation of chapter 5 in chemistry, that is mole concept. In this chapter we'll learn how to determine the empirical formula and molecular formula of the compound. As you can see here, ICSE 2015 page number 101, question number 3. I'll read out the question. If the empirical formula of a compound is CH and it has a vapor density of 30, find the empirical formula of the compound. Before solving this question, I would like to explain you few terms. Here, empirical formula. Now, what is empirical formula? Empirical formula is the simplest formula of a compound which does not show the actual number of atoms of each element present in one molecule of a compound. Now similarly, a molecular formula or chemical formula of a compound is the symbolic representation of a compound which shows the actual number of atoms of each element present in one molecule of a compound. Now what is the difference between empirical formula and molecular formula? Here empirical formula is the simplest formula of the compound which does not show the actual number of atoms of each element present in one molecule of a compound, whereas molecular formula shows the actual number of atoms of each element present in one molecule of a compound. Now next here, vapor density. VD, vapor density. What is vapor density? It is the ratio. Vapor density is the ratio of the mass of certain volume of the gas to the mass of same volume of hydrogen gas. Vapor density is the ratio between the mass of certain volume of a gas to the mass of same volume of hydrogen gas. Here relation in here you can see, you keep it in your mind, your relative molecular mass. What is the relationship between relative molecular mass and the vapor density? Relative molecular mass is equal to twice its vapor density. Here, relative molecular mass of the substance is equals to empirical formula made into N. N stands for whole number. Now here number 3, molecular formula is equals to empirical formula into N. Now here question, empirical formula as given here, empirical formula as given CH. Now second step, we will find out the empirical formula weight. Here as you can see here, atomic weight of carbon is 12 and hydrogen is 1. And we will find out the empirical formula weight of this compound. Carbon 12 into 1 plus hydrogen 1 into 1 atom. So 12 1 is 12 plus 1 into 1, 13. Here, empirical formula weight of the compound is 13. Now here next, here, relative molecular mass equals to relative molecular mass equals to twice its vapor density because vapor density is given here. So relative molecular mass of the compound equals to twice into VD. As you can see here, vapor density has given 13, so 2 into 13 is 26. We got 26. Relative molecular mass of the substance is 26. Now we have to find out the molecular formula of the compound. As you can see here, relative molecular mass equals to empirical formula weight. Relative molecular mass equals to empirical formula weight into M. Relative molecular mass mass is equals to empirical formula weight into N. What is the relative molecular mass? 26. Here we will write 26 equals to empirical formula weight is 13. 13 into N. We will find out the value of N. Therefore, N equals to 26 over 13. 13 1 is 13, 13 2 is 26. N equals to 2. Now last one here, molecular formula is equals to empirical formula. Here, molecular formula is equals to empirical formula into N. Now what is the empirical formula? CH. We'll write here CH. What is the value of N? N is 2. So C into 2, H2. This is the molecular formula of the compound. Now here we have ICSC 2011 page number 102, question number 16A. I'll read out the question. An organic compound with vapor density is 94 contains carbon 12.67%, hydrogen 2.13% and bromine 85.11%. Find the molecular formula of the compound. So here, as you can see here, what are the elements present? Carbon, hydrogen and bromine. Here first column will write element. Here. Now we'll write here percentage composition. Then atomic mass or atomic weight. Then here in third box, relative number of atoms. Then here last one, simplest ratio. Now here in question you have seen this compound contains carbon, hydrogen and bromine. C is the symbol for carbon, H is the symbol for hydrogen, Br is the symbol for bromine. Now what is the percentage of carbon? 12.67%. 12.67%. Now what is the percentage of hydrogen? 2.13. What is the percentage of bromine? 85.11. 85.11. Now here atomic mass or atomic weight of each element is given in the bracket. Here carbon is 12, hydrogen is 1 and bromine is 80. Now these two you have to find out. Now relative number of atoms and the simplest ratio. How can we get the relative number of atoms? When you divide this percentage composition of the element by its atomic weight, we'll get the relative number of atoms. Here relative number of atoms, this percentage composition should be divided by the atomic mass of each element. Carbon 12.67 is divided by 12. Now hydrogen 2.13 is divided by 1. Now bromine 85.11 is divided by 80. Now here how to divide? Here 12.67 is divided by 12. 12 ones are 12. Now 0 here, decimal sign. Put first your decimal. Then you can bring your 6 down here. 12 zeros are 0. Then we can bring this 7 here down. 12 fives are 60. We write this still here. 2 places after decimal. Here relative number of atoms is 1.05. 1.05. Now here 2.13 is divided by 1. So this will be 2.13 only. Now next here 85.11 is divided by 80. 85.11 is divided by 80. 81 are 80. Then subtract this 80 from 85. 5. Here decimal point. First here put decimal point. Then bring this one here. So 51 is less than 80. We cannot divide this 51 by 80. So first here 0 times. Subtract this 51. Then here 1. Now here 7 8s are 56, here 51. So 6 8s are 48. 6 0 0, 6 8s are 48. Now 1, 11 minus 8 is 3. We'll write till there 1.06. Now next your simplest ratio you have to find out. First of all, we have to identify the least number of atoms. Least number of atoms. Here 1.05, 2.13, 1.06. Least number is this. So when we are finding the simplest ratio, we have to divide this relative number of atoms by the least number of atoms. Here least number is 1.05. 1.05 is divided by 1.05. Here 2.13 is divided by 1.05. Here 1.06 is divided by 1.05. Now here you can see here, omit this. The digit after decimal places 1, 2, 3. This omit this one. Omit this digit after decimal. So here 1 is divided by 1, 1. 2 is divided by 1, 2. 1 is divided by 1, 1. The simplest ratio. Here carbon atom 1, hydrogen atom 2, bromine atom 1. The simplest ratio will be the empirical formula of the compound. So first of all we will find the empirical formula. Empirical formula of the compound is equals to empirical formula of the compound equals to carbon atom 1. So if there is no number we understood by 1, then second element is H, 2 atoms. Third element is bromine, 1 atom. This is the empirical formula of the compound. Next step we will find out the empirical formula weight. Empirical formula weight we will find out. How to find out the empirical formula weight? Empirical formula weight is equals to, here atomic weight of carbon is 12. 12 into 1 of 1 atom plus hydrogen 1 into 2 plus bromine 80 into 1 atom. So here 12 ones are 12, 2 ones are 2, 80. Then here this will be almost 94. Here the empirical formula weight of the compound is 94. And vapor density as given. As you can see here, relative molecular mass equals to twice as vapor density. Here we will find out the relative molecular mass is equals to 2 into Vd. Here Vd as given, vapor density 94. So 2 into 94. 2 4s are 8, 2 9s are 18, 188. The relative molecular mass of the compound is 188. Now next step we will find the value of N, this relation. Relative molecular mass equals to empirical formula weight into N. Here relative molecular mass equals to empirical formula weight into N. Here relative molecular mass is 188 is equals to empirical formula weight is 94. 94 this into N. Therefore N equals to 188 is divided by 94. 2 times. 2 4 are 8, 2 9 are 18. N equals to 2. Then last one here relation. Molecular formula is equals to empirical formula into N. Here molecular formula is equals to empirical formula into N. Here empirical formula, what is empirical formula? CH2Br. What is the value of N? N is 2. So we'll multiply this C2, 2 2s are 4, H4, Br2. This is the molecular formula of the compound. Dear children, here we have come to the end of today's online class. Thank you very much.